So far, we have been working with one single FWD raw data file and one single pavement section. But that does not necessarily have to be the case. So let's say that we want to work with more than one FWD raw data file. So I'm going to select these two here, keeping in mind that once again, I'm using the ASHTO format, but I can easily select any of the others and the procedure would be exactly the same. But by opening these two raw data files, I see that in this top left corner section of the depth window, I can select between the raw 1 data file and the raw 2 data file. And when I select each one of them, automatically the data that is shown in the rest of the window of depth relates to the data file that is currently highlighted. But in these two FWD raw data files, we can see that there's a sharp change in the behavior of the normalized deflections at approximately 230 meters. And this is very obvious, not just by looking at this normalized D1 deflections graphic versus distance, but also looking at the deflection map. We can see that somewhere at around 230, there's a change in the behavior of the deflections and in the collected data for a normalized load. And this happens for the following reason. Between 0 and 230 meters, we have a pavement structure that consists of a flexible pavement, so an asphalt concrete layer on top of a granular base. And from 230 meters to the end of the tested section, we have an asphalt concrete layer on top of a cemented materials layer. So you notice that not only the materials change, but the thicknesses between one section of the pavement structure and the next section of the pavement structure also change. So we have 15 centimeters and 40 centimeters for section number 1, and we have 13 centimeters and 22 centimeters for section number 2. This means that we are going to have to define two different distinct sections in the pavement structure menu. In order to do this, I come here to the pavement structure menu, select new, number of sections, this time 2, because I need to define 2 pavement sections instead of just 1. And the first thing that I have to do is to define the distance at which the first section. So you see that now I'm defining section number 1 of 2. Depth tells me that section number 1 has to start at distance 0, and I have to define the distance at which it ends. So 230 meters. Then I know that I have the just two layers, that the first layer is an asphalt concrete, the second layer is a granular base, that it's 15 centimeters and 40 centimeters, the thicknesses, the corresponding thicknesses, 15 centimeters and 40 centimeters. So once again, all that I have to complete left is the seed moduli for this section. And in order to do that, I go to the File menu, Single Test, and instead of selecting average alignment drop like we did before, we are going to select partial average drop. So in order to define the partial average drop, I have to define a minimum distance and a maximum distance. So I know that section number 1 develops from 0 meters to 230 meters. So I'm going to introduce 230 meters in the maximum field as the maximum distance and press done. And when I do this, depth automatically presents this additional window that relates to the average drop between 0 and 230 meters, which is the same thing as to say the average drop for the first pavement section. So I'm going to define once again the structure, granular base, 15 centimeters, 40 centimeters, And now I'm just going to introduce random seed moduli. And when I finish doing this, I can press the run button. That DAPS will automatically calculate the best possible solution. And when it does that, it automatically replaces the seed moduli for the calculated layer stiffnesses that produce this deflection ball represented in black interrupted line. And I can purely simply copy this information to here. So I have 98 for the subgrade, 188 for the granular base, and 200, 2,576 for the asphalt concrete. So I finished defining section number 1. Now now I can move forward to section number 2 by clicking on the forward button here. Now in the forward button, I no longer have to define distances because we're defining section number 2 out of 2. So the start of section number 2 will be the end of section number 1, and the end of section number 2 will be the maximum distance that is considered in the in the in the FWD tests that we have available. So now once again I can say that I have an asphalt concrete layer. So starting to define section pavement structure section number 2, a layer of cemented materials, and I know that I have 13 centimeters, not mistaken, yes, 13 centimeters and 22 centimeters. So once again, I get to the point in which the only thing that I have left to complete are the seed moduli. So this time we're going to go back to the single test, select partial average drop, and this time the distance that we want, the section of pavement that we want, is located between 230 meters and 420 meters. I'm going to press done, and automatically that calculates the average drop for section number 2. So now I'm going to introduce the data. 13 centimeters and 22 centimeters. And I'm going to introduce some random seed moduli. You notice that this time I'm introducing a seed moduli a bit higher for the cemented material because it's cemented, so it has to be a bit higher than it would be if it was a granular base. But once I have the information completed, I can press the run button, and now that replaced the information that I initially introduced as seed moduli with the back calculated layer moduli that represent the calculated deflection ball, which once again overlaps very well with the measure with the FWD collected deflection ball that represents the average drop for pavement section number 2. So now all that I have to do is copy the back calculated moduli that I got from this procedure to the FWD main window. Once I have all the information complete, once again the next button shows up. I could move back if I wanted to section number 1 out of 2, but I've already completed it, so I don't need to do that. I'm just going to press forward. Now you see that when I select a particular station, you see that that black circle moves to the distance that corresponds to the station that I'm selected. So I select station number 5 at 80 meters, and this distance here is 80 meters. So if I select station number 16 at 340 meters, here we are. So judging by the distance that is stated in the raw FWD data file, DAPS automatically associates the distance of the FWD station to the pavement structure that we defined previously. And that's how DAPS knows which pavement structure to use with with each FWD station. So now if you go to the batch analysis and start the batch analysis process, you see that once again, right now DAPS is back calculating the FWD stations of the file raw1, and when it finishes calculating all of them, it automatically was going to switch to raw2, to the file raw2, and continue until it finishes calculating the stations of file of the last of the raw2 file, which is the last in this case, and then it will automatically go into the summary results table. So now, right now, we are visualizing results for a file raw1, but if I want to visualize results for file raw2, all that I have to do is come here to this drop-down menu and select raw2, and automatically that updates the data. And the same thing for the post-processing tab. So I can visualize the statistical analysis for section number 1, and if I move to section number 2, so it automatically changes the information to correspond with the statistical analysis of station number 2. Here we have the graphic representation. We can see that we have two distinct pavement sections, one traditional flexible pavement, and one pavement that has a cemented layer and a layer of asphalt cement on top of it. So to save this information to file is exactly like we did before. I can press the save results to file, select that select a specific title for the file that I want to save, press save. That gives me that message stating that it's already back calculated everything. So now if we try to open it, here it is, the file that I just created. And you'll notice that in this file, there's a separated, a different worksheet for each of the raw data files that were loaded initially and that were back calculated by that. So we have a worksheet that corresponds to the file raw1, and if I want to visualize the data that corresponds to the file raw2, all I have to do is switch to the next tab, which is extremely easy. And if we switch to the sections tab, instead of just one, I'm going to have two sections because those are the sections that I defined for this particular case. So this, we can load, I'm using two different raw data files with two different pavement sections, but I could be using 20 different raw data files with 20 different pavement sections. There's no maximum limit to the things, to the number of raw data files that we can load, or to the number of pavement sections that we want to define. The only thing that we have to keep in mind is that when the distances, the zero distance in all the files that I load has to be in exactly the same point, and the pavement structure that I define here, the different pavement sections, have to apply to all of the files that I load, because DAPS is always going to associate the pavement structure of each FWD station to its corresponding distance in the pavement sections that we define. So everything has to be coherent and coincide.